special type of factoring, the difference of two squares or difference of perfect squares. So if we have two terms being subtracted and they are both perfect squares, we can rewrite them as a number or expression times itself is going to factor in the form of a plus b times a minus b. So if we look at the first example of this here, x squared minus 25. We can rewrite it in this form of a squared minus b squared. So a term squared minus a term being squared. Now x squared is the same as x squared, because x times x gives us x squared, so that's our first term. Now 25, what times itself is 25? 5, because 5 times 5 is 25, or 5 squared is 25. So in the general form, a squared minus b squared is a plus b times a minus b. Well, for us here, a is what? X, and b is 5. So we would get x plus 5, a plus b, times x minus 5, or a minus b. Huh? What's 5 times 5? Any other? Yeah. Oh, you're good. Questions on this here? You ready for the next one? 4z squared minus 1. So we're going to rewrite it in this a squared minus b squared form to see how these connect. So 4z squared, we can see what times itself is 4z squared. So 2, and then z, because 2 squared is 4, z squared is z squared. So 2z squared, 2z times 2z would be 4z squared. Now what times itself is 1? 1. So we have 2z squared minus 1 squared. Well, a in our case is 2z, and b is 1. So we'd have 2z plus 1 times 2z minus 1. So you're ready for the next one then. Questions on this one here? X squared minus 64. Well, our x squared would just be x squared. And what times itself is 64? Okay. So this would factor to what? X plus 8 times x minus 8. So we'd have x plus 8 times x minus 8. Questions on this here? Are you ready for the next one? X squared minus 36. So we need to see what times itself is x squared. Will that be x? And what times itself is 36 is indeed 6. So this would factor to x plus 6 times That's it. Questions on this here? Ready for the next one? 100 minus m squared. So what times itself is 100? What times itself is m squared? M. So it'd factor 2. 10 plus m times 10 minus m. Now we do need to be careful with this here, because since m squared went second, we have to put it second. Now with the 10 plus m, we could flip it to m plus 10 because they're both positive. That's fine, bless you. But if you flip the 10 minus m, it'd become negative 10 plus, or negative m plus 10. So it's better just leave it in the second spot when we factor it. Questions on this here? Are you ready for the next one? 9n squared minus 16. So what times itself would get us 9n squared? 3n. What times itself is 16? 4. So a plus b times a minus b. So 3n plus 4 times 3n minus 4. Questions on this here? Are you ready for the next one? Let's have it be g squared. Let's add it. 16h squared minus 49g squared. So we need to figure out what times itself is 16h squared, see if this is a perfect square. So what times itself is 16? What times itself is h squared? H. What times itself is 49? 7. And g squared would be? G. So we would get 4h plus 7g times 4h questions on this here? Now the last one we have on the note sheets for this part is this one here, 25b squared minus 36. So what times itself would be 25b squared? 5b. What times itself is 36? So we'd have 5b plus 6 times 5b minus 6. Questions on any of this here so far? Let's add one. Let's do 32x squared minus 50y squared. So what times itself is 32? Well, if we're not sure, we can always take the square root. Because when we take a square root of a number, we're finding out what times itself is that number. Is there a number times itself that gives us 32? Well, 4 squared is 2, but that's not what we want. So what we'd have to look at next to see is there a greatest common factor between these two terms, between 32 and 50? There is. What is it? Well, they are even, so it has to be. Because 32 divided by 2 is 16. 50 divided by 2 is? So there is no other common factor, so it is the greatest common factor. Well, 16x squared, well, 4x squared would give us 16x squared. 25y squared would be 5y. So like I said, we have 4x plus 5y times 4x minus 5y. So on this one here, we had to factor out the greatest common factor first before we could factor it. Questions on this here? Questions on anything we've done so far? We ready for the next one? Using the special product pattern to evaluate So use the special product pattern to evaluate the expression. So the special product pattern is exactly what we've been doing. So a squared minus b squared is equal to a plus b times a minus b. So 54 squared minus 48 squared, we would say that this is 54 plus 48 times 54 minus 48, because a in our expression here is 54, b is 48, a squared minus b squared. And we can use this to simplify. Because 54 plus 48 is going to be 102. 102 times 6 is 612. And that's it. We add the 2, we subtract the 2, and then multiply our results together. And we get our answer. Questions on this here? Are we ready for the next one? 68 squared minus 62 squared. So what would we do? We'd have 68 what? Times? Well, 68 plus 62 is 130. 68 minus 62 is 6. So we're doing 130 times 6. Which will be 780. Questions on this here? Let's do one more. 36 squared minus 34 squared. So 36 squared minus 34 squared is what? 140. That's it.